Hello, everybody. Welcome back to DeepRob. So we're here for discussion 3 today. The topic of this one, I changed actually this week based on our discussion last week because I thought I had a very good time in discussing progress labeler, that paper. And so I thought then, based on the positive reaction from that it probably makes more sense to talk more about research in these discussions. And so what I wanted to do today is it's going to be an informal discussion. So there's a few papers that I picked out that are very prominent within their sort of sub areas. And they're linked up on the website under today's discussion on the calendar. So what we're going to do today is just start off by having like an informal discussion so we can all kind of go around and like truly have a discussion about how it is you can approach reading deep learning research papers, because that's a skill for both practitioners, if you're just interested in going to industry, or researchers, kind of, it goes without saying, because the number of research papers that are published within deep learning and the number in grand total, but also the pace at which they're being published is massive. And so being able to keep up with the field is very, very important. And so the skill of actually knowing sort of what to look for when you're reading a paper and some sort of tips that I have for how to read papers is, I think, a useful discussion. So we'll just get right into it. If my cursor can work. All right. Okay. So yeah. So today's agenda, no administrative updates. I mean, you're all working on project 1, so that's the only administrative thing. So the way that I thought we could sort of scope this out is, first, I just want to sort of bring up a few points from my perspective as a graduate student and as someone who used to work in industry with deep learning, of what the importance is of reading papers, and then some perspective from my end, but then also we can get perspective from all of you, and we can share our different strategies on how to approach reading research papers. Because I remember when I was an undergraduate student, and also when I was like a master's student, and sometimes even now, it can be really intimidating to see a new paper that's published with some really, really impressive result and not understand what is happening in the paper. And so I think being able to overcome that feeling in the first place is really important. That's one skill. But I thought that actually explicitly talking about it in today's discussion would also probably help, because I can remember when I was an undergraduate student, I never had a discussion section, believe it or not, at this R1 university. So R1 is a classification for different universities in the US, according to the US government for funding of research. So R1 means high research output. So you might not know it, but you're at one of the highest research output institutions in the US. So I went through all of undergrad and never had a discussion formally about how to read papers and things like that. So I think this would have benefited myself. And so that's kind of why I picked it for today's topic, hoping that it will benefit you. So how to approach research papers in deep learning. And then there's 3 that I picked out on the website. So these are all very prominent papers from their respective areas. So AlexNet was one of the papers about 10 years ago. This was from 2012 that kicked off really the deep learning revolution over the past decade. So AlexNet was one of the winners of the ImageNet challenge that used deep learning. It was one of the first winners that used deep learning. POSE-CNN is from more of the robotics context for estimating what we call the 6th degree of freedom pose of rigid body objects. And then NERF is a more recent one. So NERF stands for neural radiance fields, which is it's a massive sub area, but it's an approach for rendering novel views of scenes that we'll talk about. So sort of getting into it. So here are just a very high level, and if there's questions along the way, this can be very informal. So at a high level, I put on this slide just from both the applied side and also the research side, why it is that being able to read papers is an important skill. And I would say that deep learning is potentially different from some of the other topics when it comes to paper reading. So in particular, if you're on the applied side, there's some areas where if you sort of know the classical approaches, you might not need to stay up to date with academia, because things might not be changing at a fast pace in academia. That's not the case in deep learning. So in the case of deep learning, if you're working at a company and they want state-of-the-art performance for facial recognition, or they want state-of-the-art performance in terms of accuracy for pose estimation, right, in the context of robotics, you're going to have to stay up to date with the research, because right now the research and the state-of-the-art is changing all the time, and where it's being published and being publicized is still within academia. So even if you're in industry, it's very possible if you're working in deep learning, you will be publishing, or you'll at least have to stay up to date with what's being published. And I would say the same goes for if you're interested more on just like the pure engineering of these things. So if you're interested in building up the systems that support deep learning techniques, so that what I mean by that is if you're working on like the backend infrastructure, like the actual server clusters that would be responsible for handling the requests maybe from a robot, or on the robot hardware itself, and you're worried about how you're going to balance the energy that's being used for processing, let's say the perception versus the planning versus the motor controls, all of those areas are also being affected by the academic research. So achieving like high energy performance of our neural networks is an active area. So if you're going to want, if your employer is going to want you to reach some new benchmark that was just established in academia, you're going to have to understand the fields from the standpoint of the papers that are being published. So that's on the applied side. On the research side, if you want to contribute to the field, the first thing that really you have to understand is what has the field done already. And so being able to read through literature and understand what other researchers have done is kind of necessary before you could see areas that you could contribute to that haven't already been covered. That's also, I think, one area that's very intimidating as a young researcher is like being willing to expand your own knowledge and see what others have done. Because a lot of times what you'll find, at least what I found, is you'll have an idea that you think is really, really original and awesome. And then you build up the courage to look at what others have done, and you find that actually people had this idea maybe even decades ago. And so you can save yourself years and years and years of time in the lab if you spend it in the library. So there's a great expression, which is exactly that. It's, like hours in the lab can save decades, or sorry, hours in the library can save decades in the lab. And it's really true. So that's one reason on the research side. The other reason is that there's a lot of really, really smart people doing research, and they're thinking about problems and data sets and applications within robotics that you might not think about, but you might think are really, really cool once you see them. So NERFs, what we'll see today, is like one example that I think is very recent, that has caught like a lot of researchers kind of by surprise of what you could do with neural networks. And then that opens up a whole new lane of research that you would never maybe otherwise would have gotten into if you hadn't been staying up to date on the field. So these are two reasons for both the applied side and the research side that I think makes reading papers important. Yeah. And like I said, if you guys have thoughts or feel free to, you can raise your hand if you feel comfortable with that or speaking up. This can be very informal. So just to look at a few examples of how it is that the state of the art is changing, what I've done here, it's probably a little bit smaller than I would have liked, but I just took a few snapshots from some benchmark data sets and challenges that exist within deep learning, kind of broadly within the context of robotics and computer vision. And what they're showing here, so these are taken from a website that's called Papers with Code, which I'll point out is a great resource for finding papers that are interesting and finding implementations of papers that exist if you wanted to build upon some of the results that you see. So what we're showing, so like in the top left, this is the ImageNet challenge, and what's being shown in this graph is the top one accuracy on the vertical axis, and then over time on the x-axis. So 2023, this year, there's already been a huge number of papers published that fall within that have been kind of applied to this challenge. And you can see that actually the number of papers that are at least being documented by this website, which is not a complete list, is actually growing over time, right? So there's sort of more and more competitors on that challenge. But the same goes for other tasks. So like in this middle one, so 3D human pose estimation, which we might want, a robot to be able to perform if it's going to be interacting with humans in space. Again, we can see like there's a lot of papers being published, and the baseline is constantly kind of improving. So in that second figure, the metric is better for being lower. But then also, so like another example, robotic grasping. And I'll point in all these figures, like on the far right-hand side, that's either 2022 or 2023. So these are all changing, in real time. In this lower pot, like once again, this was a 3D object detection in a kitty data set. So that's in the context of autonomous cars. Again, the state of the art is still improving. Then the final snapshot here is just the number of data sets that are documented by this particular website. It was, I believe, 7,656 data set papers. So that's another thing to point out. So in the context of deep learning, oftentimes what will happen is a data set itself will be published and publicized as a paper. And so if you want to know what data has been collected to train maybe some new model, it's useful to look literature to find what data sets have been publicized. And then another useful tool is sometimes, if you're working in industry, you might be working with a data set that's proprietary, but you want to publish your model to share it with the external world. You can use a public data set, and you can search for public data sets that you could still apply your model to not expose like proprietary data. So state of the arts are always changing, and so staying on top of the literature is an important skill, but also a very daunting skill, right? Because there's so many papers being published, so we can't read them all. So the next thing then to kind of ask is, okay, so there's all these papers apparently being published. Where can I find these papers? So what I put on the slide here are a very small set of conference venues and journal venues that are, I would say, prominent within the robotics community. They're certainly the conferences that our lab, the Laboratory for Progress, targets, generally speaking, for publication. But this is not a complete list. So it's very possible that you're working in a lab here at Michigan that targets other venues. So don't think that if you don't see a conference on this page that it's not like a robotic conference, because there's many others. But this is just like a sampling. So to give a sense, so ICRA, International Conference on Robotics and Automation, CORAL is the conference on robot learning. Robotic Science and Systems covers like a broad, both ICRA and RSS, Robotic Science and Systems, covers not just deep learning, but other methods and techniques within robotics. IROS is another one. And as just like a kind of side note, one exciting fact is that IROS, which is one of the major robotics conferences, is actually being hosted in Detroit this coming year. So in the fall, there's going to be a huge Michigan robotics presence, of course, at IROS, because it's like 30 minutes away. So if you're still going to be with us, if you're graduating this semester, that's exciting. Maybe you could come back to Detroit for next fall. But if you're still going to be a student, I would expect like a huge number of Michigan students to go to IROS, both to present, but also to see the presentations of published work. And then on the right-hand side, so Science Robotics and IEEE RAL, Robotics and Automation Letters, those are two prominent journals. So if you're wondering what's the difference between a conference paper and a journal paper, generally speaking, painting with a broad brush, journal papers tend to be longer, and they tend to kind of go into more depth and be more complete compared to conference papers. Within computing and within robotics, again, I'm painting with a broad brush. This differs from lab to lab and from graduate student or faculty member to faculty member, but generally speaking, conference venues are the main venue for publication. So you'll probably see and read more conference papers than you will journal papers. But that can vary. Everyone's experience is different. So these are some of the main venues where you can find peer-reviewed. So that's the other big distinction between like conferences and journal papers and what we'll talk about in a second. So all these venues would be peer-reviewed. So if you see a paper published in one of these venues, it means that it's gone through a review process where, anywhere between, we could say 2 to 4 to maybe even 5 peers in the field. So those would be other active researchers in the field. They could be graduate students, faculty members, postdocs, who are not involved with a project or with a paper that's been submitted to one of these venues. They've reviewed the paper and found that it has novelty, it's contributing to the field, the ideas would be valuable for other researchers. And so you can, to some extent, that gives sort of a reputability to the work. At a high level, that's the peer review process. It's a way of ensuring that the information that the community is using to generate new ideas has been kind of vetted and is trustworthy. Did not mean to do that. Oh yeah, so embedded in the links in this PDF is a link to all of these venues. So if you wanted to read, for example, or see like what was prepared for like ICRA 22 at that program, you could click on the link on the image that's embedded in the PDF, which I accidentally did there. Okay, in contrast, another source of papers that I suspect many of you are familiar with already is what's called arXiv. So this would be like an open access venue that just hosts essentially any PDF that someone decides to upload. They do vet to some extent, but they're not vetting based on like novelty or contributions to the field. They're vetting on like, we can think of it as they're basically not vetting it. So, you could upload a PDF from like a class project, for example, to arXiv. And in fact, some students do that. So but generally speaking, nowadays, many researchers will publish both to arXiv and then also submit their papers to a peer-reviewed conference or journal. So a lot of the times you'll see papers appear on arXiv before you'll see them actually presented at a conference. So it's still a very valuable resource. I use arXiv all the time. One useful tool about arXiv is you can actually subscribe to specific kind of topics. So for example, I'm subscribed to these 5 subjects. So computer vision and pattern recognition, computers in society, machine learning, neural and evolutionary computing, and robotics. And so when you upload a paper to arXiv, you can choose sort of which field you think your paper falls into, or multiple fields. And then every single day, arXiv gets updated with the new papers. So this was taken from the email that I got this morning. And you can see that in the past 24 hours, 190 new papers falling into these, I think, 5 subject areas have been uploaded. So you can imagine if every single 24 hours, there's about 200 new papers being uploaded to arXiv, it's very, very difficult to stay on top of all of them. In fact, I could not read all the papers. There was a time when in my first semester of the PhD program, I was reading every single abstract that was posted under these categories. And I do actually think I probably wouldn't do maybe every abstract, but I do actually think if you want to get like a good sense of what work is being done, drinking from that fire hose for just like a short period of time it's actually a good skill, because you'll pick up a whole lot of new words and you'll like terminology from these subfields just from the abstracts, and you'll start to get a sense of how you can pick a paper that you'd be interested in versus not interested in from the abstract. So it's way too much for you to do like on a consistent basis, but it's actually I found it to be a good exercise for a period of time. So if you're interested in subscribing to that on arXiv, you can sort of like create an account with your email, and they'll email you these papers. Usually it's like 4 a.m. in the morning that they send the email. Anyway, so that's one resource for finding papers. Yeah.
I've heard about like shops.
Mm-hmm. Yeah, that's actually, yeah, I failed, I think, to put that. I should have put that on the slide. That's a really good point. So the question was like, you've heard maybe something about workshops, and you could like maybe submit a paper to a workshop. How is that different from a conference, right? So yes, so generally at conferences, certainly at all of these 4 conferences that I've listed here. So I should talk about what is a conference. So a conference is there's a physical meeting. So there's actually, so this is in contrast to a journal. So for a conference, they pick a location. So like, for example, IROS 2023 in Detroit at, I don't know if it's Cobo Hall, but at a convention center in Detroit, there is going to be on the order of a few thousand people that will come to Detroit from all over the world, and they will present their papers at this conference. They will confer, share their knowledge at this conference. And so generally what that looks like, I mean, from program to program, from conference to conference, it can vary, but generally there's a combination of poster presentations where for an accepted paper, the authors would prepare a fairly large poster. I mean, like kind of like my arm, my wingspan by width, by height. And so they would present their paper that way. Sometimes papers get kind of research talks. So there'll be maybe like a 10-minute talk to go along with each paper, but it varies from program to program. But as part of these conferences, also what exists are what's called workshops. So essentially different subfields in the context of robotics, within robots, will have workshops for maybe like probabilistic inference might have a workshop. So all kind of algorithms that would be using probabilistic inference for maybe like SLAM algorithms, just so that those localization and mapping algorithms we talked about a week ago, or doing like particle filtering. So there'd be a workshop that's kind of dedicated to that topic. And there would be papers or maybe poster presentations or maybe talks that are specific on that sub area that are usually still like works in progress. So they're not as complete as a conference paper. They're usually shorter. The results are usually not at the level that you would need for like a full conference paper. And they're usually like sort of the workshops are usually less formal than the full conferences. But you could think about it as like a conference within a conference. So that's just one example of a workshop. So there's others. So there would be, there might be workshops on like bipedal locomotion might have its own workshop, or you might have a workshop on aerial vehicles in a certain context. Like they tend to be sort of broken up by subject area. But that's a great point. Yes, workshops are also venues that you could consider publishing. I think one of the goals, honestly, from this course and for the final project is like, we would hope that you would actually generate a final project in that 2-page white paper that would be viable for a workshop, or potentially with a bit more work, even a conference submission. That's really our goal as instructors, is to get all of you to the point where you can produce new ideas in the field and contribute to the field. Yeah, great question. Say that again. In-house publications? Do you know like an example? Okay, yeah, interesting. So I suppose what I would be familiar with that's maybe the closest is, so for example, like IEEE. So that's a professional society within electrical engineering, or like ACM, the Association for Computing Machinery. That's another professional society within computing. They, I wonder what the right terminology is. They can sponsor like journals or conferences. So they're, but I'm not sure about like an in-house publication that would sort of just be with IEEE. I'm not familiar with that, but I'm sure it exists. There's a lot of venues for publishing. Yeah, it would be counted as a publication. I think anything that is published, that is public, is a publication. When you start looking, like when you start talking within academia, there will be distinctions between conference publications, journal publications, which conference you're publishing in, which journal. And when I say distinctions, what I'm saying is like the prestige of different publications can change based on the venue. Of course, the subject area will change based on the venue. And so in other words, where you're publishing can affect the perception of the work. Over time, I think that's less true. Over time, like citation count is maybe one way to measure impact, but over time, it's more so like the impact that a work has on the field. It doesn't really matter where it was published. It's more so just like, what effect did it really have? What did it really contribute over time? Yeah.
So, assuming a team is able to, create a final product that, maybe something that they publish, what would be a conference that, would it be IROS or that deadline?
Yeah. Okay. Yeah. So interesting question. So the question for those online was like, with the intention of this class being preparing you so that your final project would be viable for a submission, what deadlines would be possible? So RSS is the next major conference deadline, and that is February 4th, I want to say. So probably not RSS. IROS is then a month later. So IROS is at the end of February. So for the main conference. So I don't know about there. Generally, I think the ICRA workshops would take submissions, I want to say like towards the end of the semester. So an ICRA workshop would timeline-wise would sort of fit well, but we don't have to constrain ourselves too much. Like you don't think of constraining yourself too much to like, what's the nearest publication deadline for the end of the semester. There's always places to publish. There's always new deadlines coming up. So worry more so about the work, and then we can worry about the publication. Yeah. But I love the ambition for that, because I do think it's possible to do. Okay. All right. So yeah, so archive is one place to look. Publishing never stops. It's always happening. Let's see, what do I have? So we looked at this. We looked at the 190. Okay. So given that staying up to date with the literature is an important skill for both researchers and practitioners, and seeing how many publications and publication venues there are, that sort of sets up this idea that it's a challenge, right? It is hard work to stay up to date with literature. So one thing that we should try to then develop is a skill when it comes to how it is we pick which papers we read in the first place. But then once we've committed to a paper that we're going to read, then we should think about what kind of how we should approach reading it in a way that where we're going to get the most information that we can, but do it efficiently and do it in a way that is kind of respects the work that went into the paper in the first place. So this discussion obviously has a huge caveat, which is everyone has to develop their own style. So when you're doing research, everyone has a different style for how they actually conduct research. Everyone has a different style for how they present it. But also when it comes to reading, everyone is going to have their own style. So what works for me and the ideas that I'll kind of put forward are, you might find a different style works better for you. And that's totally okay. But these are sort of things that I found to be useful. And if you have other suggestions, I think it would be an interesting discussion, because a lot of us here are graduate students or are undergraduate students who are doing research or who have developed some of these skills. So it's a good idea to share our knowledge. Okay, so some questions that I think about when I start reading a paper. So the first one is, what's the primary field and what's the subfield of the paper? Because even if I'm reading a paper that's, let's say, from one of those 5 archive broad subject areas, those cover a huge number of fields, right? I mean, they can cover everything from like pure computer vision to what I would call robot perception. They could be controls. You'll see controls using deep learning methods. They could be coming from the medical community using deep learning for like X-ray and like cancer detection. So there's all of these different fields that are overlapping when it comes to deep learning. So the first question I have is, which of the broad fields does it come from? Is it from robotics? Is it from computer vision? If so, it'll be more related to the research that I'm interested in. Then the next thing is, what subfield does it come from? So I have done a lot of work in pose estimation, where we're trying to estimate, once again, like the 3D position and then the orientation of objects in space. So if I find a paper that's from within pose estimation, that's going to be more of interest to me than if I find an image segmentation maybe model. So I might put more emphasis on reading those pose estimation papers that come out as soon as I can over some of those other subfields. Just because for my research, those are the ones that most affect what I'll be working on. But that's the first question. And usually I would say you can get a good sense of what the primary field and subfield is from the title and the abstract. Usually you don't have to read further or look further for that knowledge. The second thing, though, is what is the problem that the authors are trying to actually address? So even if I understand that maybe a work is within robot perception, it's within pose estimation, there's still different aspects of pose estimation. So maybe the problem is trying to address the accuracy of just rigid body opaque object pose estimation. So it's just trying to like incrementally improve the accuracy of existing techniques. That might be one problem. Another problem might be, we've found some new objects, like transparent objects is one example, or maybe deformable objects was another example. And they're trying to now propose applying pose estimation to this new domain. There's these new objects. It's a new problem that we're trying to apply pose estimation techniques to. That would be like another example of how understanding what the problem is can be useful for trying to understand what the paper is doing. And the reason why is because both of these informations, it's going to give you some context once you start actually looking at what the authors did. So at that point, then, given, let's say that I know that the authors are going to be trying to maybe incrementally improve the accuracy of just like opaque object rigid body pose estimation, like from the YCB video data set, maybe as an example, the next thing then that's worth trying to understand is what progress have other researchers made? So generally speaking, I guess I should point out, so for the first 2 questions, let's say you could get that from the abstract for the first question. And then usually there's an introduction section where the authors will discuss broadly, like what is the problem area that they're trying to address. Maybe they'll give some high level idea of how well they've addressed it in this paper, but that's where they're really motivating the work. The third question about what other researchers have already done in this area, that's usually addressed in a related work section. So generally the authors will be expected to describe what has already been done that could be considered similar to this work, or what have others tried maybe that hasn't fully covered the problem that they're trying to address, and to make that clear for the reader so that you can actually understand the contributions that are being put forward. So then it's, once you understand what others have done on this problem, then you can start to put into context what the major claims of the paper are and what the contributions are. I would say increasingly papers will put an actual list of what the contributions are for their work with, like, usually it's like at the end of the introduction. Not all papers do that. There's not a requirement that they do that. So if they don't have an explicit list, sometimes it can be a little bit harder to find what the contributions are. But at this point now, you'll have a contextual understanding of like what's been done, and now what this paper is setting up to propose as like the real benefit to the field. it's essentially like these contributions are, what are other workers or other researchers in this area going to take away from this paper that's going to give them some new power that they didn't have before, some new ability, right? Whether it's a model that has increased accuracy, or it's a new data set, or maybe it's an understanding that some existing neural networks can be applied to some new estimation problems that they didn't think about before. That's really what the contributions are meant to describe. And at that point, then the question is like, did the authors achieve these claims? Like, what are the key results that they're showing? Did they improve accuracy? Was it by a small amount? Was it by a large amount? Is the data set that they're producing going to be valuable to me? Is it going to be valuable to the community? And then finally, actually, maybe not quite finally, but then you can look at like, what are the real technical details? Like, how did they actually achieve these improved accuracy results? Or how did they collect this data set? What techniques on like a very low level did they actually try using? Did they provide code that I could maybe look into to try and replicate some of the results? And then also, like, if they're measuring accuracy, how are they measuring it? Is it measured in a way that I've used in the past, that I have some understanding of? And as you go along with these different questions, what you'll probably find is that there's going to be references to other work that you'll have to read to actually understand the full paper. And then finally, the last question, and this usually comes at the conclusion or the discussion, is like, what is left to be done? Like, what are the unanswered questions that this work is sort of motivating? Or what are the new problems that I might be able to apply some of their techniques to? So that's where you as a researcher can start to generate some new ideas and see like what you would want to do to extend the work in the future. So these are just some of I would say like these are like the core questions I think about when trying to read a paper. More concretely, what I usually do when I read a paper is I always start with the figures and use the text as like a last resort. So part of that is because I'm a very like visual oriented learner, I think. So generally speaking, I can pick up a lot more information from a figure than I can from text, because text is very dry. So normally what I'll do is I'll just go figure 1 through figure N and read the caption along with the figure. And that's how I'll actually answer most of these questions. If it gets to the point where I'm interested in the work, it's related to the research that I'm doing, and I think that the key results, which are usually shown in a figure or a table, are motivating to me, that I think that they're worth understanding, then I'll go to the text to actually understand what techniques they're using. If you read a paper straight through, what I find is that it's very slow, and you'll generally spend a lot of time on papers that ultimately are not going to be that applicable to your work, from my perspective. Like I said, though, everyone has a different style. I'm curious, so for those of you in the room, I'm sure by now, most of us have gone through and started reading papers on arXiv or research papers. Does anyone think I'm missing anything when it comes to reading papers, or did any of these really stand out as like, oh yes, I always start with the figures, or I always start from the conclusion and work backwards up? Like, what do people think? Yeah.
I would say sometimes because some of the implementation
Yep. So we had this point that a lot of the times reading code, getting access to code can be super valuable, because there's implementation details that are often left out from the paper, but would have to be in the code, like maybe like a learning rate or some other hyperparameter setting is, I'm guessing what you're talking about. Yeah, that's super valuable. And I would say a trend, like within computer vision, this has been around for a while. Generally speaking, the expectation is you'll publish your code with your paper. So to get it accepted at a top tier conference, generally speaking, you have to make your code publicly available. I mean, you can license it in different ways, but you have to make it available. And if you don't make it available, generally speaking, the reviewers will want to know exactly why you're not making it available, from my experience. There is a caveat to that. I would say, the robotics community is moving towards that increasingly. So increasingly, robotics reviewers will want you to publish your code when it comes to deep learning. The caveat, though, is I think, and the historical reason why I think robotics research has sometimes published their code less than computer vision, is that if the code is dependent on a specific robot platform, it's very unlikely, at least in the past, that the robot platform was very widely available to other researchers. So your code wouldn't, if you're writing code for a robot where there's only one of those robots in the world, which is how it used to exist in the past for some platforms, your code would not be useful to other researchers to replicate because that robot might not exist. That's one argument I've heard. But increasingly, I'd say the field, especially with deep learning, is moving towards just everyone should always be publishing your code for reproducibility, and that is a good I think, direction and goal. Yeah, so that's a great point. I don't know, other things people are finding as they're reading research papers on arXiv or finding other good sources for finding papers. Yeah.
I only have like a little bit of experience, but what I was kind of told at my last job was abstract, introduction, conclusion, just get the gist of it. And then as soon as possible, because I was working in private, they were like, see if the code is available. If it's not available, then just take away like the concept, some of the technical terms you learned, but there's really like, you're trying to look for something that you can implement to solve a problem. More of that practical side that you talked about earlier.
Yeah. Great point. So yeah, so like from some industry experience, what we shared for those online was like try to get the gist of the paper as quickly as possible. So maybe like skim through like abstract, introduction, conclusion, and then try and find code if it's available so we could actually use it as a tool. That's a great point. Another thing I would say is if you're finding a paper that you're really interested in where they don't have source code, you can contact the authors of the paper and ask for source code or ask if they made it available somewhere where you didn't find it. Of course, when you want to be very, very nice in your contact with them. But that's also possible. So on some papers, you'll see explicitly listed like a corresponding author, and that's the author that's meant for any questions or concerns is who you should contact. Sometimes there's no corresponding author, and in those cases, I would probably default to the first author. But that's another kind of approach you can use if you want to get code that is not like listed on a GitHub link. Yeah. Okay. So yeah, so these are some questions, some approaches you can use for starting to read papers. So now what I thought would be useful, so we still have about 15 minutes left, is just to kind of go through, I mean, this won't be a super in-depth paper reading. We'll just kind of skim through some of these papers together just to get a sense. But I picked out these 3 prominent papers, and I thought it would be a good exercise to sort of look through them together. So let's see. So if I exit out of here, so let's look at AlexNet. Yeah. So the link is up on the website under today's discussion and also embedded in the slides. If you click on that, you'll have a link directly to the paper. So here I've got the paper. So this was a conference paper, and this was, I want to say it was NIPS. Yes, so this was NIPS 2013, if I'm reading it correctly. So that's Neural Information Processing Conference. Let's go back to the paper. So I'll point out, yeah, so this is AlexNet. So that name, that abbreviated name is based on the first author's name. In addition, though, Jeff Hinton, let me make sure I'm highlighting the right part. Yeah, so Jeff Hinton, so that's one of the Turing Award winners for his work on deep learning. He was a faculty member for a long time at the University of Toronto. And so this was this paper went along with the winning solution to the ImageNet challenge in 2012, if I'm remembering correctly. So we're going to be talking more about this particular algorithm in a couple, I think, weeks or maybe next Thursday when we look at convolutional neural networks in lecture. So some of the concepts within this paper we haven't talked about on the structure of the neural network side, but to get a sense of how to kind of go through a paper, so you can see, so we're starting out with the abstract, and this gives like the highest level summary of what the paper is about. So it's going to be trying to summarize in 1 paragraph, sometimes 2 paragraphs, all of those questions that we talked about. It's like what's the field is kind of implicit, but what's the problem that's trying to be solved? What results have been produced that others maybe hadn't produced in the past? What are the techniques that were used, and what's left to be done? So you can see, for example, here they're describing that they're producing, let's see, so they're saying, even in this, so you're seeing they trained a deep convolutional neural network on this classification problem. So right off the bat, we see what problem they're trying to solve. It's an image classification problem. You can see that they're applying it on the specific data set from ImageNet. And then they're showing their key results just even in the second sentence, right? So on the test data set, they had a top 1 and top 5 error rate of 37.5% and 17.5%, which was, they say, consistently better than previous state of the arts. So just like right there, right, they've already answered most of those core questions that I laid out, right? Maybe they haven't had future directions yet, but we know, okay, it's within computer vision. They're trying to solve the problem of image classification, which at the time had not been sort of, did not have like a 95+% state-of-the-art accuracy. So it was not a solved problem. Even now, it's not a solved problem. We know what techniques at the high level they're using. We know what the key results were, just in 2 sentences, right? So instantly, right off the bat, you see a lot of the paper. So kind of scrolling down for the sake of time. So like, let's do maybe my approach and look for figures. So one thing that's a little bit different about a lot of papers you see now is generally you'll have a figure 1, which will be on the first page. I mean, this depends on the venue, but a lot of the times now you have a figure 1 on the first page, which tries to capture the audience's attention. You can see back then, and so it'll usually have like a lot of color. There'll be more of like diagrams that have like clip art or to some extent like actual images to try and capture attention and get the reader interested. You can see this did not have a figure 1 in that style. So here in figure 2, though, we can see the overall network architecture. So if you were going to try and replicate the results, they're laying out here a lot of the hyperparameters from the network architecture side that were chosen that go into this paper. So this would be a figure, if you really wanted to actually understand the techniques of the paper, that you would know instantly you would want to look into. And so the way you can kind of see that is, first of all, it's a very complex figure, right? So you have both numbers, but then also you have these architecture figures, which are representing the features that are going to be built within this neural network. And it seems to be for the entire network, right? So you can see here, they say it's an illustration of the architecture of the CNN. So CNN is an abbreviation for convolutional neural network. And it's explicitly showing the delineation of responsibilities between the GPUs that are being used. So a GPU is a short term for graphics processing unit. So the Colab notebooks that we're working on are built on GPUs to make the algorithms more efficient. So scrolling down, so there we have like the details of the architecture. And so here you can see that here now, this is kind of interesting. They have an entire section on reducing overfitting. So here's like yet another section where if you're practicing deep learning, you're going to realize like, okay, here's going to be a lot of hyperparameters that I would want to pay attention to if I was going to try and replicate this paper, because reducing overfitting, they mentioned this, I think, later on in the abstract, which I skipped over, but reducing overfitting was one of the big kind of accomplishments that this paper kind of contributed in its ability to actually achieve the state-of-the-art classification performance, because they had such a large network in comparison to what had been tried in the past. The approaches that they used to reduce the overfitting was one of the key contributions. And so scrolling down further, then we have more details of learning. So here now is an interesting figure, visually at least. So like this would be a figure that would be like capture my attention and say, oh, like I'm kind of curious about what are these? Okay, so these are the convolutional kernels, right? So we've kind of been seeing in our linear classifiers and our SVM that like the templates that were used. And we talked last lecture about the bag of words code book. So this figure here should sort of look similar to that. And so building some so like as you're reading these papers, you can start to see how you can contextualize like your knowledge with what this research is doing. Is you could start to maybe say like, okay, so these convolutional kernels, this is probably like the templates from our linear classifiers, and then start to use that knowledge to, as you read the text in detail, to place the results in context. So then you can see like down here is where they have tables. So here you can see they're going to be comparing their accuracy, it seems like, of their networks with maybe the existing state of the art from the past. And then towards the end, okay, and then they have a more interesting figure, right, where they're actually showing the results that would be on the classification problems. So like that's like a very high level skim through that paper. I know we're running, actually we're out of time, so I didn't get to the other papers. Just briefly, I'll point out, so like this paper you can see does have a figure 1. So I wouldn't even read the abstract of post-CNN. I would just start with this figure, because instantly you get, what's the input? Well, it's going to be an image. It's like, okay, so now I know it's in the context of like computer vision, maybe robot perception. It's going to be some deep learning approach based on this feature transformation that's being shown. And then what are the outputs? So the outputs they're saying is 60 pose in the form of a 3D rotation and a 3D translation. And then also some semantic labels, which are going to be like pixel-wise predictions of what every pixel corresponds to in terms of objects. And then maybe there's some information sharing, but ultimately it's going to be from an input image to a 60 pose. So instantly from that one figure, I know what area they're in, what problem they're trying to solve. And then if I scroll down, you can see, okay, so now I have like a network architecture. So if I wanted to re-implement it, I know I'd be spending a lot of time here. Scroll down further. Now I can see sort of maybe this is the data set that they were working with. So as a side note, the YCB video data set, which is a very famous pose estimation data set, comes also from this paper. So this is a highly cited paper for pose estimation. And then you can see, okay, a big table with results for accuracy of pose estimation, and then some qualitative examples to show how well they can operate. So that's like a super fast skim through of the paper, but you can see how you can start to, I think, looking at the figures gives you a quick sense. The last one, now this is like I was saying, like this is like a really exciting area that has really visually cool results. For the sake of time though, we kind of ran out of time. So as maybe some fun for the weekend or like your Friday night, if you're looking for something fun to do, is to skim through the NERF paper. This is this paper sparked a huge explosion of work within these neural radiance fields that still is ongoing. I would say of all of the subfields within deep learning, at least for the past 2 years, I think NERFs have probably the highest density of and pace of publication, because like this paper came out and then all of a sudden it felt like maybe 10 NERF papers a day were coming out. I mean, it's probably not quite that much, but if you're interested in NERFs, I would suggest starting here. And so what are NERFs? Like, why do I sound like they're so cool? So just at a high level, what they do is the following. So they're going to take in a data set of input images. So like on this far left side, so there's some scene. In this case, it's like a drum set. And in this paper, it's all static. So it's like a fixed scene. And what we're going to do is we're going to take images from all these different views. So all of these different, what these black kind of pyramids are showing is the pose of a camera at different locations around the scene. So we're going to collect a data set that has like all these different images taken from different views. And then we're going to try and train a neural network where the input would be a pixel location. So like an X and a Y coordinate, and also the pose of some novel camera. And we're going to hope that our neural network can take in the XY coordinate of some pixel in a new image and render out the color that should kind of go into that pixel given that input pose of the camera. So in other words, you input into the neural network an XY coordinate of a pixel and a pose of some novel camera location. And we want it to output the correct color that would correspond to that pixel if you actually had a physical camera in that novel view. So what that means is if that worked, which it does, is like you could then, as a continuous value, you could imagine moving like a synthetic camera anywhere around the scene and render out novel views of this scene. And so the reason why a lot of roboticists have tried now using NERFs for all sorts of problems is because in some sense, if this neural network is able to do that rendering, it's like it's encoded all of the spatial and optical information about the scene into one network. Like all of the information that you would need to know about where objects are located and what the colors are and how the light is interacting with the objects, somehow it's all baked in. So there's like a lot of potential, we think, for those networks to use for downstream tasks like pose estimation or semantic segmentation and things like that. So yeah, as homework for this weekend, read through this paper. And there's a lot more related papers on the website under a neural radiance field section. So if this sparks your interest, this could be the subject for a final project. And so with that's the topic of today was how to read deep learning research papers.
All right. Can I jump in real quick? So I just wanted to I want to thank everybody again for your continued interest in coming out on Friday. But I wanted to let people know, I'm going to embarrass Anthony here for a second. Anthony just had a paper on differentiable non-parametric belief propagation that just got accepted to one of the major journals in our field. I think you should give Anthony a round of applause. He's not just talking a bunch of nonsense here that he can't practice, and Anthony can back it up. So that's good. He knows what he's doing. So thank you. All right, I'll let you close things up.
All right, yeah. Thank you for that. Yeah, it was like 8 p.m. last night. We got the notification. So anyway, yeah. So thanks for coming out. Happy to stick around and answer questions, or if you guys want to go through that paper in more detail, if you have time, happy to do that too. But all right, yeah, I'll see you next Tuesday.